Example 8, simplifying the derivative of a quotient. So here we have the function. You can see it's a quotient because we have a numerator and a denominator. Both of them are functions. So we're going to use the quotient rule. Okay? And remember, the derivative of the quotient is the denominator times the derivative of the numerator. So this would be the denominator, this would be the numerator, minus the numerator times the derivative of the denominator all over the denominator squared. So let's go through this one, see if we can do that. So f prime of x equals, this is the f prime of x right here, okay? G of x. So we can think of g of x being x squared plus 4 to the 1/3 power. Typically, writing it in exponential form rather than radical form is going to be more advantageous for calculus. So x squared plus 4 to the 1/3 power times the derivative of the numerator, which would be 1, minus the numerator, which would be x, times the derivative of the denominator. So the derivative of the denominator, this is the chain rule, okay? And when we do the chain rule, we're going to start off by doing the power rule. So I'm going to have 1/3 out in front, x squared plus 4. Subtract 1 from 1/3, so that's going to be negative 2/3 power, times the derivative of what's the inside function here, so that's going to be 2x. All over g of x squared. Oh, and I got to replace g of x with x squared plus 4 raised to the 1/3 power. So now let's begin to simplify this. Well, this right here, that's just going to become x squared plus 4 to the 1/3 power. Then notice we've got x times 1/3 times 2x, so let's do that first. Got this minus sign, so minus 2/3 x times x squared plus 4 to the negative 2/3 power, divided by, okay, so if you take 1/3 and square that, that is going to be 2/3. Okay. So let's see. Next I can divide here. Notice right there, I have like bases. So when I divide by like bases, I subtract the exponents. So 1/3 minus 2/3 would be negative 1/3 minus 2/3 x. Now I'm going to divide this way. Again, when you divide like bases, you subtract the exponents. So negative 2/3 minus 2/3 would be negative 4/3. Okay? Next, here is where we are going to factor out the power of least degree. So notice that we have two factors, right? These factors are the same, and then they have different powers. So you're going to factor out power of least degree. So we're factoring this guy out of each of these. So in order to do that, you might want to have some scrap work on the side here. Okay, and what we're doing, we're factoring out x squared plus 4 to the negative 4/3 power from both of these. So this first one, again, this is when you divide like bases, you subtract the exponents. So we're going to be left with x squared plus 4 to the, let's see, negative 1/3 minus negative 4/3. That's going to be plus, so that's going to be 3 over 3, which will be 1. So that's going to be the first power. So I can just leave it like that. Minus 2/3 x. And then again, when you divide like bases, subtract the exponents. Negative 4/3 minus negative 4/3, that's going to be 0. So this whole thing, x squared plus 4 raised to the 0 power, that's going to become 1. So you don't really have to write anything there. I'll write it there just to demonstrate. Then let's simplify this. So we've got x squared plus 4 to the negative 4/3 power. Then let's see, we got x squared plus 4 minus 2/3 x. Remember, that's just 1. Then I have x squared minus 2/3 x. Well, that's going to end up being 1/3 x squared plus 4. And this negative exponent, we bring this down here. And then I could multiply the numerator and the denominator by 3. The numerator would end up being x squared plus 12 all over 3 times x squared plus 4 to the 4/3 power. And that would be our answer.